Hi, this is Denise, and today I'll be performing our gummy bear lab. I did have kind of a fail because when I left my gummy bear inside my cup with water overnight, it did sadly explode. So it just literally dissolved completely. And this was just the gummy bear that was put inside the water. I did put an extra one this morning, but unfortunately it's not going to allow me enough time to perform the experiment, and plus I do go to work soon for clinical trials or clinical research, so I'm just going to go ahead and go through what I went through, whether if it was a fail or not. So before I start, I'm going to go ahead and define a few things. Osmosis is the movement of water molecules from a solution of high concentration of solutes to a solution of low concentration of solutes through a semi-permeable membrane. In simple terms, this means that water will flow from area of high concentration to low to try to reach an equilibrium. Another key term is going to be a hypertonic solution. When two solutions are compared, the solution that has a higher concentration of dissolved solutes and exerts greater osmotic pressure is called hypertonic solution. And then hypotonic solution, so this is going to be the difference, hyper versus hypo. Hyper means usually overactive, and then hypo usually means underactive. So hypotonic solution, the solution that has lesser dissolved solvents and exerts lesser osmotic pressure. So those are the key terms that we definitely need to know in order for us to perform this lab successfully. So besides the regular gummy being put inside of the cup, I basically had 3 cups. I put in my or not 3 cups, 2 cups. 1 cup consists of water and salt, NaCl, and then the other consisted of just the pure water or tap water. I do live in Los Angeles, so maybe that's the reason why my gummy bear exploded. I did leave it for about 7 hours. Uh, and the other gummy bear was just my control, and this is how it looked. So unfortunately I don't have my regular water. H2O gummy bear that didn't survive exploded. So you can see that the salt water definitely shriveled up the gummy bear, and this is compared to the normal size gummy bear. Okay, and then we would expect that the H2O gummy bear would display a larger than normal size. So instead, it would be a bigger gummy bear compared to the normal control. So I think you could see the size difference. So let me go ahead and discuss what happened. The sugar in the gummy bear acts as a solvent, and gelatin holds a semi-solid solution inside the gummy bear. And the gummy bear acts as a semi-permeable membrane for the solution inside. So in simple terms, a semi-permeable membrane means it's selective in which it allows to come in and out. And in this case, it's going to be water, the movement of water. That's what osmosis is, movement of water. So when the gummy bear is placed in my normal tap water, the gummy bear has a higher concentration of dissolved solvent, which is the sugar, and thus the water flows into the gummy bear through osmosis, and the gummy bear will swell up because water moved into it. The water is hypotonic to the gummy bear. So basically my gummy bear got so fat that it exploded. uh, and then when the gummy bear is placed in the saturated salt solution, the one that was looked shriveled up at the end. It is placed in a hypertonic solution. Thus, the water will flow out of the gummy bear, and the gummy bear will look deflated or shriveled. So yes, does look shriveled, and that's compared to the normal one, the control. And so that's going to be my experiment for this week. I do apologize for my fail with my exploded gummy bear. I attempted to put another one to try to save it later on, but unfortunately it's just not going to work out. Thank you so much for watching.